All right, let's do a couple more practice ones. So on my last exam for 3101, I said, right, give me some algorithms that we covered in this course that have this running time, right? And I hope people would say, well, I got two friends and I cut each input in size half, right? That sounds like merge sort to me. That sounds like quick sort to me, right? And I think most people got it. But anyway, let's do this. Top work is into the 1, right? C is 1. Base cases is into the log A over log B, which is n to the log 2 over log 2, which is n to the 1, right? So we have a linear number of base cases, which kind of makes sense because when we do merge sort, every number only appears once, right, in each layer. And at the base case, we have one base case for each number by itself, right? So they're in base cases, each with one number, right? So here, C equals log A over log B. So the total work is what? Right? It's the work that each layer has work in. And we have log n layers. Right? Does that make sense? What? It's because the depth of the tree, right? I have two friends, they have two friends, they have two friends, but the depth of the recursion is log n. Right? What? Yeah, so let's do binary search here. What changes in binary search? How many friends do I have? Right? What do? I have a list, I cut it in half, I keep one of the halves, and I recurse, right? So my number of friends is 1. And how much work do I personally do? I just look at the middle, right? I'm only doing constant work. So I'm really doing into the 0 work, right? This is, right? I do work 1. Right? So here, the top is into the 0. Right? And then, how many base cases are there? It's log of 1 divided by the log of 2. Now we have to know what the log of 1 is. It's, right? It's 2 to the what gives me 1. 2 to the 0 gives me 1, right? So this equals to the 0, which equals 1, right? It tells me that I have what? 1 base case. Does that make sense? Well, there's me, and then I have one friend who has one friend who has one friend who has one friend, right? So there's only 1 base case. Yeah? A is how many friends I have. B is how much the input gets smaller, right? I cut the list in half. That's why B is 2. Right? A is 1 because I only have one, I only do 1/2, right? So I only get 1 base case. Hmm? Yeah, my friend gets half the list, right? I recurse on one friend with half the list. No, I'm only calling it a recursing once. That's why A is 1. Yeah. Right? Everybody get that? And so in this picture, I have an input of size n, my friend's n over 2, his friend n over 4, n over 8. How much work they're doing? They're all doing work constant, right? So the work at every level is the same. So the running time is the work at one level times log n, right? The running time of binary search is log n, right? All right, so let's do another one. Let's do this. I have 2 friends. This is before. And my friends are half the size, right? I cut my input in half and give half to each friend. But somehow I only do constant work, right? So then the top layer is into the 1, and log A over log B is into the 1, right? No, the top layer. Sorry, this is wrong. Top layer is into the 0, right? I'm not doing any work, constant work at the top layer. So then we compare 0, right? The top work is less than this work, right? So the work is dominated by the base cases, right? We still form this tree where every item is by itself. So we have n base cases, but each level each guy does a constant work, so the total work is n. Right? People get those 3 examples? We're going to do binary trees later. All right? All right, so now we're going to do an example where if my input's of size n, I give my friend an input of size n minus 1. And then the running time will be exponential. All right? And how many of you heard of Towers Hanoi? You done it? Right? There's an easy recursive algorithm, but if you're trying to do it just by yourself, you get muddled. And remember, you might know that I spammed you over Christmas, and because my girlfriend was working on it, and I came up with the way this way of just helping her do it. But we're not going to do that today. We're just going to look at the basic recursive algorithm. All right? So the problem is we have n disks, and they're stacked up. The rule is you can never put a big disk on top of a smaller disk, right? They have to be in order, and you have to get them from there to there, right? So we can it's daunting how to do it, right? But we're lazy, so we're going to get some friends, right? So here's the entire algorithm. I know at some point I have to move the big disk from the source to the destination, right? And when I do that, where are all the other disks? N minus 1 disk must be in the middle, the spare, right? So the work I personally do is moving that big disk, right? Now, how do I get them over there? Well, that's a recursive call, right? I get my friend to move n minus 1 of them, right? And then I get a friend to move n minus 1 of them again, right? Does that make sense? Everybody get this algorithm? And you can imagine if you're doing it yourself, it gets confusing, right? So on the 3101 exam, just last term, I thought I'm going to give them a really easy recursive one. Just give me the code for a tower of Hanoi. And of course, half the class get it perfect and half burn, right? I mean, it's just the nature. So I think it's such elegant code that we should look at it. All right. So there are three towers, three poles here, right? We can call them pole 1, pole 2, and pole 3, right? But they have different roles, right? So for me, one of the three poles is called the source, and the precondition is that there are n of the n smallest disks are on the source, right, for some n. Now, there may be a lot more disks. They're bigger, and they're spread out in some weird way on the other poles. But I don't care about them because we're never going to move them, and they're all bigger, so we don't have to worry about them, right? So I have the input n, and we have the n smallest on the source. And what's the post condition is those n have moved over to the destination, right? So the input to the problem is going to tell me which is the source pole and which is the destination pole, right? Now, once I know those two poles, the spare is the pole that isn't one of those, right? So I could figure out what the spare is, but to save me work, my boss is going to tell me who the spare is, all right? So source, destination, and spare are going to be first, second, and third pole in some order, right? So that's, everybody get the problem, right? Now the base case, it could be a single disk, but I love 0. So if I have 0 disks to move, then I'm done, right? Otherwise, what do? I get my friend to move n-1 disks from the source to the destination, from the source to the spare, right? And then I move the n disks from the source to the destination. And then my friend moves n-1 disks from the spare to the destination. Right? Does that make sense? That's the code. All right. And you can think the first paragraph says, if you start in a company, maybe you start and you figure out how to move 0 disks. And then you learn how to move 1 disk. And then you learn how to move 2 disks. And when you have 2 disks, you have a friend to help you move 1 disk. And when you have 5 disks, you have friends to help you move 4 disks, right? And you can move up in the hierarchy, right? And then when you're in the boss, right, you have friends to move n-1 disks, right? So what's the running time of this? Well, I'm personally moving 1 disk, right? And I have 2 friends, and each friend has n-1 disks, right? So you'd see the key difference between this and what we were doing before is before it was n divided by b, right? We were doing damage to the n. But now we're not really. We're just making it a little smaller. So now the math here is hard enough. So let's get rid of the +1, right? And if you get rid of the +1, really it's asking how many times do you move the small disk, right? And then what is this? Well, you see it keeps doubling, right? Every time you have more disks, it doubles, right? So the total is 2 to the n. You have to move the top disk, the small disk, 2 to the n times. People kind of follow that? Right? In fact, you can say, well, the total is 2 to the n minus 1. Why? Because these guys do this, and this guy does 1, and this guy does 1, and it adds up. So I wouldn't give this too much thought. All you should know is that if my input that I give my friend is just 1 smaller, and I have 2 or more friends, then it's going to be exponential time, right? If I only have 1 friend, that's okay. But don't have 2 friends. And that's, right, that's just with 1 friend, and that's it. That's just saying here when we're subtracting, if you're subtracting off something, then you should just know it's going to be exponential time. Loop invariant, we didn't, of which code? The Powers of Hanoi? Yeah, so it doesn't have a loop invariant because there's no loop. But the precondition is that the n smallest are on the source, and the postcondition is that you move them to the destination. Any questions about this?